All right, guys, this last video on dividing with radicals is this third section called rationalizing the denominator. All right, okay, and take this down where it has purpose. So our whole purpose is we want to eliminate an irrational number in the denominator, which is the bottom of a fraction. Okay, let's remember, this is one of the first lessons we did in the year. What's an irrational number? An irrational number is if you have a long, ugly decimal like pi. All right, and to be more direct is if you take a look at 1 and 2, square root of 3 and square root of 6, if you put those in the calculator, like square root of 3, I think it gives you like 1.73, and I don't know what the rest is, but it's an irrational number. Now what's going to happen is, and you're going to see this a lot next year in geometry, you don't want to be left with the square root of a number in the bottom. All right, that's not a perfect square. Because if it's a perfect square, you can take the square root of it and get a whole number. But for number 1, I don't want to be left with this square root in the bottom because it's really an irrational number. So it's going to be real simple, actually, how to get rid of it. If you have a square root in the bottom that you can't simplify, that means it's irrational. What you would do is, to get rid of it, we would multiply the top and bottom of that fraction by whatever this bottom irrational square root is. So we're going to multiply top and bottom by square root of 3 over square root of 3. Now when we multiply this, when we multiply 2 and 3, I can't combine them and get 6 or square root of 6 because 2 is not in the square root and 3 is. So we just combine it as 2 root 3. All right, so that's just 2 root 3. Now the bottom, this is the part where we're going to get rid of the square root. So if I multiply these by my product property, since both of these are in the square root, I could say this is the square root of 3 times 3, which would give me the square root of 9. Now you can see the whole purpose of that is the square root of 9, well, that's a perfect square. 9 and 3 squared is 9, so that's 3. So you get 2 root 3 over 3. All right. So what you can see, what we basically did was this square root, I got rid of this and I moved it to the top. All right, you're going to do this all the time in geometry. So next year, next year in geometry, so the next one, this square root of 6, that's an irrational number. You can't take the square root of it. So I'm going to do what I just did the last one. Last one I multiplied top and bottom by root 3 over root 3. This one, I'm going to multiply top and bottom by root 6 over root 6. All right, so root 6 over root 6. So then when we do this, again, when I multiply these, I can't multiply them together because 5 is not in the square root. So I just have it as 5 root 6. When I multiply square root of 6 times square root of 6, that gives me square root of 36. And then square root of 36 is just 6. So our answer for this is 5 root 6 over 6. Now here's kind of the shortcut. You can see whenever I multiply a square root of 6 times the same thing, square root of 6, see how I just get 6? Here I multiply square root of 3 times square root of 3 and I eventually get 3. So sometimes we can kind of skip this step. All right, if you're not seeing it, you can still do this step, but it's going to wind up being just a whole number in the bottom. All right, and we're going to do all of these. Okay, let's go to 3. Now 3 and 4 are different in that everything's in the square root. Now remember the last couple videos we said simplify the fraction. Now 4/5 and 1/3, they don't simplify. They're already simplified for us. So we can split them up right away and make it square root of 4 over square root of 5. Now this is good. Square root of 4, that gives us 2. So I'm going to leave it as 2 over square root of 5. Okay, let's try to zoom in here because it's kind of getting a little tight. All right, and then we're at the same point that we started with 1 and 2. This is an irrational number. Right, square root of 5, I can't simplify that. So I want to get rid of that square root in the bottom and move it to the top. So I'm going to multiply the top and bottom by this root 5 over root 5. Okay, then when I multiply this, I can't multiply the 2 and the 5 because 2 is not in the square root and 5 is. So that's just 2 root 5. And then this, square root of 5 times square root of 5 is square root of 25. And square root of 25 is 5. So my simplified answer for this is 2 root 5 over 5. Okay, when I look at 4, as I said, 1/3, it doesn't simplify any further. So I can split it up and say it's equal to square root of 1 over square root of 3. Right? That's my quotient property. Okay, good thing, square root of 1. 1's on the list, perfect squares. Square root of 1 is 1, so we're left with 1 over root 3. All right, and then that square root of 3 is in the bottom. That's irrational. So to get rid of it, I'm going to multiply top and bottom by root 3 over root 3. So then 1 times root 3 is square root of 3. And then square root of 3 times square root of 3 is the square root of 9. And then this, that's a perfect square. Square root of 9 is just 3. So my answer is root 3 over 3. All right. Let's see here. Let's see what else we got. 5, 6, and 7. All right. Let's do. I can still get done the last 3. Okay. Number 5. Just like 3 and 4, this 5 over 2, I can't simplify 5 over 2. So I can split it up and say it's square root of 5 over the square root of 2. Okay, but again, the whole goal is I want to get rid of this square root in the bottom. It's all right to have it in the top. So to get rid of this irrational number of square root of 2, I'm going to multiply top and bottom by square root of 2. So we're going to have square root of 2 times over square root of 2. Now the one thing different from this is that when you multiply the top, the numerators, they're both in the square root. So I could use my product property and multiply them both. That's just like saying the square root of whatever 5 times 2 is. Well, that's 10. So that 10's in the square root. And then I can multiply these together because they're both in a square root. So that's square root of 4. Now the whole key was this. Square root of 4, that gives me 2. So I'm left with square root of 10 over 2. Now you might be looking at this and thinking, oh yeah, this is equal to 5. But I can't divide these because 10's in the square root and this 2 is not. So that's it. That's our answer. Okay. You know what? Let's just do one more. Let's just do number 6. Now number 6, unlike the last 3, 3, 4, and 5, the 18 over 10, I can simplify that. All right, so 18 over 10, they're both even, so 2 goes into each. So 2 goes into 18 9 times, and then 2 goes into this 10 5 times. And 9 over 5 you can't simplify. So then once we do that, we can use our quotient property. We can take the square root of 9 divided by square root of 5. Okay, this should stand out. That's a perfect square. Square root of 9 equals 3. This, I can't take the square root of it, so it's an irrational number. We're almost done. All right, this is irrational. I want to get rid of this root 5 and basically move it to the top. So I want to multiply top and bottom by square root of 5. As I said, you're going to do this all the time in geometry next year. Okay, when we do this, now I can't multiply the 3 and the 5 because 3 is not in the square root. So I just leave it as 3 root 5. Here I can multiply these together and leave it in the square root because they're both in the square root. So square root of 5 times square root of 5 is the square root of 25. And the square root of 25 is 5. So my answer is 3 root 5 over 5. All right. So this last video is basically telling you do everything that you did before with quotient property. Simplify the fraction first, then you can use the quotient property. But your answers, if you have fractions, you should never, ever, 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 ever have a square root in the bottom.